This video will be going over cis-trans isomerism for organic chemistry. We'll start off with some of the simple stuff and work our way up to more advanced cis-trans isomers. This molecule right here, it's very easy to see that it's trans. Trans just means opposite or changing side. So this methyl right here changes sides across this plane to be on this side. They're trans to each other. This molecule here we would call cis because we have our methyl groups on the same side. Cis just means same. But this molecule right here, we don't have any of the same functional groups. We have a methyl, an ethyl, a bromo, and an iodo group attached. But we can still identify whether it's cis or trans. But instead of using that terminology, we would use what we call entogen or zoosamin. Now, entogen means opposite side, while zoosamin means Z same side. That's how I remember it. So that would be cis. You could also remember that E and O are both vowels, and those go together. So we see that for this molecule, when we look at the functional groups, we see which ones have the highest molecular weight. Obviously, the bromo and the iodo will have higher molecular weights than any of the carbons attached. So they are on the same side, making this a Z molecule. Now going down to some more advanced stuff, we're going to talk about cis-trans isomerism in cyclohexanes. Now if we had something like this, a cyclohexane, and we had two methyl groups coming both out at us, we could easily see that this is cis, right? And if these were to be going down, that would be trans. But what do we do if we get a chair molecule like this? we could see that this is a cyclohexane in chair conformation, but we have a methyl group going out and a methyl group going up, aka an E and an A, and this is at the 1, 2 position because 1, 2. 1, 3 would look more like 1, 2, 3. We won't worry about that. How do we determine if these are cis or trans? Well, there's a fancy little table that you can use, and you don't have to memorize this entire thing. All you have to memorize is that cis 1, 3 is EE. 1, 3, EE for cis. And the whole rest of the table will fill itself out from there. Because when we write in our 1, 2 and our 1, 4, we just have to put opposites. So if it's EE for cis, we're going to go A, E for trans. If it's EE for cis 1, 3, our 1, 2 will be AE. Likewise, over here. And then this side has to be opposite, so we'll go EE and EE. So looking at our molecule, we have a 1, 2, AE. We'll go to 1, 2, AE. We would call this a cis cyclohexane, and it could be drawn out like this, where 1, 2, cis.